Okay, 7b, what percentage to the nearest whole percent of this population would be heterozygous for the Rh factor? So heterozygous, of course, that part of the formula is represented by 2pq. That's what they're asking for, and they want this in percentage, right? So let's just make sure we calculate all that. There is a second part of this question, but before we move on, let's do just that first part here. So if we go back to 7a, we find out that our p-value is 0.6. And we found out that our Q value was 0.4. That's just taken from the previous part of this question, 7a. All we're going to do is insert that into the formula. So we got 2 times 0.6 times 0.4. And our 2pq now is going to be equaling 0.48. Now they do want this in percentage, so we just move that over two places, or multiplied by 100. So just move it over 2 or multiplied by 100. And our percentage is 48%. Okay, so that's part of the question, but the rest of the question is how many people does that represent in the study? So we have to actually go back and take a look at a few numbers to find out what the total percentage is, or sorry, the total number of people in the study. We're going to take this decimal, and it must be a decimal, you don't use the percentage, and we multiply that, just like all the other ones we did previously, by the total in the study. So we have to go back, take a look at a few questions. We found out that the positive people, there was 1,260. The negative people were 240. Add those together, and we come up with this number here being the total of 1,500 people. So when we multiplied 0.8 by 15, that gives us 720 individuals that are actually heterozygous. Okay, and that's the second part of the question. Any questions about this, just give me a quick email. Thanks, guys.